All right, we're back. And so this section has the header male female differences with a question mark after it. So in this section, I'm going to talk about, some things that maybe indicate that males and females aren't as different. One of them is assertiveness. Typically, assertiveness is one of those things that is listed under, more male or masculine traits. We've got aggressive on this list. We don't see assertiveness, but we have dominant listed as male traits. Assertiveness is sort of standing up for yourself, speaking out when needed, asking for what you want directly rather than sort of hoping that the other person figures out what you mean by the request that you're lodging, things like that. So, just to understand this graphic, any place where it's just pink and white is where women are more represented there. Wherever it's just blue and white, that's where men are more represented there. And then pink and blue alternating is anytime that there's overlap. So first off, you're going to notice there's a lot of overlap between males and females. Where you see differences is where you're looking at the 25th percentile region. That's where this person is only more assertive than 25% of the population. You see that females are way more represented in that area. Actually, if you look a little bit more to the left at the 5th percentile, you see that women are way overrepresented there also. And then as we continue to move to the right, we're now at 45%. That means that the person scores higher than 45% of the population. You see that males are a little bit overrepresented in that area. You see a little bit of females overrepresented in the, hold on, is that blue or is that pink? Yeah, that's pink. In the 55th percentile area, you see women are a little bit overrepresented in the 55th percentile. But then from 65th percentile to 95th percentile, you see that males are overrepresented. That there are way more men in the higher ends of the assertiveness scale than there are females. Females tend to be clustered towards the lower end of assertiveness. Males tend to be clustered towards the upper end. So are there male-female differences? Well, yeah, the extremes tend to be, distinguishing, females are on the low extreme, males are more likely to be on the high extreme. But there's an awful lot of overlap between males and females on assertiveness. So I guess this chart kind of makes an argument for, yeah, there seems to be differences, but also not that great of differences, not that big of differences. How about this one? Still with our question mark here. Are there male-female differences? So if we look at sex differences on the WISC-R, that is short for the Wechsler Intelligence Scale for Children. So this is an intelligence scale that's very common, really standard, very standardized, and you expect a normal distribution from an intelligence scale. So what we're looking at here is that the females are in the darker black line, and they are closer to average. Like their peak is closer to the average. In fact, it shows 101.41 is the mean score for females. Whereas for males, the mean score is 103. So you see that lighter gray line is a little bit to the right of the mean score of 100. So you see males with their average score a little bit above 100, right, 103. And then you see that the gray line is a little bit to the right of the dark black line, which means that males are a little bit more likely to have higher scores on intelligence than females for a little bit longer. Like their standard deviation is a little bit higher. But it doesn't look that dramatic, right? And so typically we say that there are really no sex differences between males and females on intelligence. And part of the reason why we say that is because if you average out males and male scores and you average out female scores when we're children, we see the pattern on the right. But when you look at the left, which is the plotting of the scores that the males and the females tend to generate, you see that females are much more likely to display average scores on intelligence. Their scores tend to cluster around 100. You've got some number of females that are down below 80 and some number that are above 130. but most are clustering around average. Whereas for males, they have way higher rates of low IQ scores and way higher rates of very high IQ scores. But when you average those things out, you end up with not really recognizing that the distributions are different for the two sexes. That males are overrepresented in the lower scores and the higher scores, and females are overrepresented around the mean. Like females look like a normal distribution. Males look like an inverted U. So there is a difference, in fact, between males and females on intelligence. The averages are basically the same, but the reason why they end up with those average scores differ. So that's kind of important and potentially meaningful. So whatever trait we're talking about, we will call it trait X. We are going to have to expect that there's going to be some overlap. So if we imagine that the blue area is the males and the pink area is the females, and we've got those little turquoise lines that I attempted to draw vertically from the tip of the distribution down. We've got the average scores for the males and the average score for the females represented by those turquoise lines. We see that there's a lot of overlap between the males and females between those means, right? There's a lot of similarity between the sexes on probably whatever trait we're talking about. Pretty much every trait that's been measured, there's a lot of overlap between males and females on, psychological or personality-based traits. So I wanted you to watch this TED Talk, and I want you to listen to how she explains the effect of congenital exposure to stress. Congenital means you're in the womb and mom experiences stress that affects the developing baby. So she's going to talk about that a little bit and how that can affect sex differences and brain development. The data that she has is rat data. So be aware, it's rat data. We don't have too much that's similar to that on humans. We definitely don't have the ability to check the dendrites immediately because that requires, I'm trying to think of a nice way to say what happens to the rats. They get sacrificed for the purposes of then doing slides of their brains and looking at their dendrites. So we can't do that to humans, I am happy to report. So we only really have the rat data so far. So go ahead and watch this TED Talk, and I'll see you on the other side.